Hey guys, so we're at the airport. We have a couple of time to wait for the actual plane to get here, so why don't we do some practice? So I can do the sum
Jetstar
question
Flight
or the matching engine
134 to
question.
the Gold
What
Coast
might be a
is
good one
ready
to
to
do?
depart. All passengers should be on board the aircraft at gate
Let's do the
1.
matching engine
This
using a
is the
heap.
final call.
So, so let's talk about what the heap might look like first. So the heap is going to be used for a matching engine for a order book. An order book is going to have a bid book and a offer book. Bids are going to store the resting orders for bids, so those are people who are wanting to buy securities. Then the offer book is going to store the resting order for offers, and these are people who are wanting to sell their security that they have. One important characteristic is that in order for a bid and an offer to cross, or for a trade to be executed, the bid price must always be equal to or greater than the offer price. This makes sense, as for the offer, they wish to sell a security for X amount of money, so they should always be guaranteed to pay that much. One interesting thing to note is that we will always execute for so that the incoming aggressor, so the aggressor order will always have the advantage. So we'll always be executing at the price of the resting offer. So if the offer was in the offer book, in the order book, and there was an incoming bid, then we execute at the offer price, given that the bid price is greater than or equal to the offer price, and vice versa as well. In order to match our price time priority, where price is the first priority and then the time, one example that I can think we can have is we can have a dictionary where the key is going to be the price, and for the value we could have a queue of orders where the queue is a FIFO
Paging
queue,
the
first in,
10
first out.
remaining passengers on Jetstar Flight
First in, first out. So the
134.
DQ part,
The
we can use the
10
DQ for it as
remaining
it has
passengers on
a
Jetstar
better performance
Flight
of one constant time hopping from the
134.
left,
You
hopping from the
must
front
go
of the queue.
immediately to gate 1.
So we
Your
can use a
aircraft
DQ,
is
and that
ready
will
to
keep track of
depart
the time
and
priority
all other
part.
passengers
In order
are
for the
waiting
price
for you.
one, let's think about it for the bid book. In the bid book, we'd always be matching an incoming offer to the best bid price possible. And what is the best bid price? It is the highest amount that someone is willing to pay for a security. So by using that, we can always find the highest number.
Qantas Flight
We can always use
3
the highest
to
number
New
for the bid
York
price to
is
find
ready to
the
depart.
bid,
All
to find the price
passengers
party.
should be on
And
board the
similarly for the
aircraft
offer book,
at
the
gate
best price would be the
8.
cheapest.
This is the
We have
final
a list of
call.
outstanding offers, and then if a bid comes in, someone would want to buy the security for the lowest amount of money possible, right? So for the case of our offer book, the best price would be the cheapest possible. A good time performing way I can think of that we can implement this is we can use a heap. So for the offer book, we'll use a minimum heap where the smallest price point will be at the very top. And for our bid book, we'll have a maximum heap, which has the very highest point at the very top of the heap. Python by nature, by using the heap queue, a heap queue is a standard Python library, so that's good. We don't have to do any additional imports. Yeah, but Python by nature, using the heap queue model, normally does a minimum heap. So that's fine for the offer book. For the bid book, what we can do is we can negate the values when we store them into the heap as to somewhat simulate a max heap, but then when we pop it or we look at values, we can negate that against to get the original value. So yeah, does that sound like a good viable approach? Yeah. For now, we'll just do adding orders into the order book and matching orders between each other when they cross. So first things first, let's import the heap queue module. This will allow us to use the heap Python module. And before we get into the actual code, I think we need to set up some objects that we'll be using. So one is the order object. And let's write the initializer for this. It's not the constructor. The standard method is not the constructor, but the initializer. We've got to know that the constructor is more like new,
Paging
and the reason it's not a
10
constructor is because
remaining
it has
passengers on
So
Qantas
for order ID,
Flight
what
3
would be a
to
reason for
New
that comment?
York.
Order
The
ID.
10
Order
remaining
ID sounds
passengers
like
on
a
Qantas
reasonable
Flight
order
3 to New
to come
York.
in.
You
And
must
the
go
direction of the order.
immediately
This is
to
a
gate
bid. This is a
8.
bid or
Your
a
aircraft is
or
ready
an
to
offer.
depart and
The
all
next
other
is the
passengers
simulated
are
as well.
waiting
So
for
if we
you.
has this order, the next it says the security. So which security are they wishing to buy on this order? And let's have the price. So this is the price per security, and then lastly we can have the quantity. So this is going to be how many of it do they wish to buy. Quantity being an integer and the price being an integer as well. So let's initialize these fields.
Jetstar Flight 202 to Sydney is ready to depart. All passengers should be on board the aircraft at gate 18. This is the final call. Flight 3 to
Sorry.
New York,
Yep, so
you
once we
must
finish
go
that, that's not gonna
immediately
be a
to
class,
gate 8. Your
order,
aircraft
or
is
it's
ready
order
to
class.
depart and all
Another
other
class that
passengers
we
are
might
waiting
have
for
is
you.
a trade class, and these will keep track of all the trades that have occurred between when a trade has been executed. So let's write the init under method for this. So we can have a trade ID as well. Let's have it a string. Let's have the buyer. It's going to be the string. The seller. It's going to be the string. Let's write the security.
Air
So what
New
security
Zealand
they
advises passengers on
traded.
flight
The price, an
24
integer,
to
and the
Vancouver
quantity is an
that due to
integer as well.
engineering
And
requirements,
once again,
your
let's
flight has
initialize
been
the
delayed
values.
and is now expected to depart at 9:05 p.m. from gate 9. Air New Zealand apologises for any inconvenience caused by this delay. Jetstar Flight
So now that we have the order and
202
trade class
to
set up,
Sydney
I
is
think we
ready
can
to
get started
depart.
to write
All
our
passengers should be on
order
board
books.
the
Let's write
aircraft
the order
at
books
gate
before we actually
18.
get into
This
the
is the
matching
final
engine. So
call.
the first order book that I would like to write is the bid book. So maybe before I get into it, I'm just going to talk about how I would implement
Paging
this.
the
So there's going to be a
5
dictionary,
remaining passengers on
which keeps track
Jetstar
of
Flight
the price, and it's going to be DQ of the
134.
orders.
The 5
So let's
remaining
implement this.
passengers on
Collection
Jetstar
DQ.
Flight 134. You
Collection
must go
DQ.
immediately to gate
Then I'm going to
1.
have a heap.
Your aircraft is ready to
I have a
depart
heap.
and all other passengers are waiting for
I'm going to
you.
have a heap that stores only the price points, and then that price point is going to map to a dictionary value, where the dictionary value has a bunch of orders in a queue, first in, first out. Now, I need to keep sure that the heap and the dictionary are well maintained, because the
Paging
value
the 10
exists in the
remaining
heap but not the
passengers
dictionary.
on
And if we do
Jetstar
try to look for it,
Flight
it's going to cause it does a key error because it
10
literally doesn't
remaining
exist. So we need to
passengers
ensure that
on
those two are
Jetstar
tightly
Flight 202.
so
You
whenever I
must go
change that
immediately
dictionary,
to
I should
gate
probably be changing the
18.
heap as well.
Your aircraft
Save
is
for
ready
pushing
to
and popping.
depart, and all other passengers are waiting for
So
you.
I'll push into the heap and the dictionary when a new price point is being made, and I'll pop when there are normal orders for a given price point. So that sounds good. Let's get started writing. So let's go to a bid book, and then the under init for this self. It's not going to take any parameters. It's going to have a book. It's called a dictionary, and it's going to have the maximum heap. Let's write a maximum just to be a bit more explicit. And then our first method is going to be add order. Self and a bid is going to be coming in, which is a type of order. So first thing we need to check is does this bid price exist in our book? If bid price not in self.book, if it's not in it, this means that this is the first order for this given price point. And if that's the point, we're going to create a new mapping. So bid book.price, and it's going to be a new DQ. I'm not sure if I need to do that, but I think it's good to do it.
Paging the 5 remaining passengers on Jetstar Flight 134. The 5 remaining passengers on Jetstar Flight 134. You must go immediately to gate 1. Your aircraft is ready to depart, and all other passengers are waiting for you. Jetstar advises
And then
passengers
we'll
on
make sure that our
Flight
heap, we're going to be pushing to
154
our
to
heap.
Brisbane
So
that
heap
your
push,
aircraft
first pass in our max heap, and then we said that we're going to negate the value such that we can simulate a max heap. Let me just write it. Negate price to simulate max heap. And then once that exists in there, we actually got to append the order to our DQ. So self.book bid price dot append and the bid. Okay, I should probably write it here. So this is going to be a dictionary, which the first value is going to be an integer, and the second is going to be a DQ. sounds good. So that's good enough for add order. Now let's look at what a match function might look like. So for the match function, we'll be intaking an offer, which is a type of order as well. Let's say this is going to output, no, it's not going to do anything, so none. Let's say this is going to output a list of trades that have occurred. So that's the other list here as well, list of trades. So we're going to have a list, so let's call it executed trades. It's going to be a list of trades. And initially it's going to be an empty list, and then we'll be returning this executed trades. Cool. So the first thing that we actually need to check inside our match function is that does there exist any orders at all for any given price point? And are there any not price, but are there more quantities to be traded for a given offer? And if that is the case, the next thing we need to check is the price. So let's pick the best possible price. We said for the best possible price, the bid book, well, it's going to be the top of the maximum heap. So we can simply look at the top of the heap, but we have to memorize that when we inserted it into the max heap, we negated it, so we simply have to negate it here. The next we said, what we're going to do is we're going to check if the best price is greater than or equal to the offer price, and we can ensure that there will always be orders for this, and then we can work on it later such that we can always be ensured that there will always be orders for a given price. So if this is true, this means that we can now successfully do our orders. So let's access our orders. So for order in self.book best price. So this is going to be DQ. So let's change that into a list. It's going to make a snapshot of it so that we can iterate through it. This is good because if we don't do this, then we'll be mutating the DQ as we're iterating through it, and this does cause some errors. So does it show us what order is? Order is unknown. So order is going to be a type of order. Or maybe I'll do here as well. So DQ of order. And I should know what order is here. Yeah. Let's find out the amount to be traded. So amount to be traded. This is always going to be the minimum amount of quantity in this and the minimum amount in offer.quantity. This ensures that none of those two can go beneath 0, because going zero doesn't really make sense, because that means we're going to be trading more than we wanted to. So that's a weird one. So we'll still check both of it. Cool. And then we're going to create a new trade object that records this trade. So it's going to have a trade ID. Trade ID could be something. Let's just set it to 1. It's going to be something arbitrary, so it's going to be something. And the buyer is going to be, in this case, the buyer is the bid. So this is the bid book, so it's going to be the order.person. The seller is going to be the offer.person. The security is going to be, we can get it from
Air New Zealand,
I'm going to get it from
flight
order.
147 to Brisbane is ready to depart.
And the price,
All passengers should be on board the aircraft
trade
at
and the
gate
quantity going to be the
15.
amount to be traded.
This is the final call.
After we've created that, we can append that to our executed trades. Now, one thing that we need to check is that, let's say in this current resting order has been completely fulfilled. In that case, we need to pop it from a DQ, as there's no point in having that order there anymore.
Aging Jetstar Flight 202, departing passenger,
Isabella
Taucamo. Paging Jetstar Flight
if the order.quantity is smaller than or equal to 0, it should be never smaller than 0, but I think
You must go
it's
immediately to gate 18.
case,
This is the final call. The offload process has begun.
if that's the case, we can pop from our DQ. Now, after we've processed all the orders, let's say all the resting orders for this price point has been completely fulfilled. If the case, there's no more outstanding orders in the DQ for this price point, right?
Jetstar advises
So we want to
passengers
delete this
on
because it
flight
still exists in the heap and it still exists in the
154 to
dictionary.
Brisbane that your
And the code
aircraft
will
will now
seem to
depart
suggest that
from
it still
gate
exists.
lounge
So we have to
9.
check. So if not, self.book
Jetstar
best price.
advises
Let's check is
passengers
the
on
DQ empty.
flight
If it is empty, we're going to be
154 to Brisbane
delete
that your
this
aircraft will
mapping
now
from our
depart
book.
from gate lounge 9.
And then we're also going to pop heapq.heap pop. We're going to pop from the maximum heap as well. Cool. Now that was all the case if the best price, so the best price is bigger than or equal to the offer price. But what if it isn't? let's think about it. If the best price can never suffice the offer price, then no other prices that are less than the best price, because the best price will always be the maximum, no other prices that are less than the price will ever suffice the offer price. And at that point, there's no point doing this loop at all, and then we can simply break off. This means that there might be some outstanding trade, there might be some outstanding offer quantity in our matchbook. Then we also, then we also need a, we'd also need to return, we need to return that.
Air New Zealand Flight 147
So
to
we're gonna return that
Brisbane
so
is
that
ready to depart.
any
All
outstanding
passengers should be on board the
outstanding
aircraft
quantities
at gate
can be
15.
created as a
This
new
is the
order
final
in the
call.
offer book. Yeah, does that makes, yeah, that makes sense. We're using that as a tuple. So this looks like a pretty good bid book. Now let's try go into our offer book. So for our offer book, we're gonna have a min heap. It's gonna be taking in a offer. So we're gonna check. So in this case, we are using a minimum heap, so we don't have to negate it as it is minimum heap by default. Offer our price, and we can append our offer. For a match, we won't be getting a offer, but we're taking in a bid. Simply, we can reset it. We don't need to negate this again. And then for this case, our min heap would be, so the smallest value will be at the top. And then we said before, for an offer, the bid price must always be greater than or equal to the offer price, and the offer price here being the best price. So we just have to flip the symbol as well. And that's the case, we can iterate through the DQ. So change the offers to that. Then we also need to change this here. So we said the first parameter is going to be the buyer. So the buyer in this case is going to be the bid.person, and the seller is going to be the order.person. They pop from the min heap, and then we return the bid quantity here. Okay. So that sounds like a good offer book and bid book to me. Now let's create a quick matching engine to see how these actually might be working together. So when we first initialize this matching engine, not construct, initialize using the integer method, we're gonna have a bid book, which is a bid book that we created, and we're gonna have a offer book. Let's also have a list of executed trades that records all the trades that have occurred so that we can keep track of it. And then we can have one method called match. This will take an order. We don't know the direction of the order yet, so it's just going to be type of order. And then so it's going to output a list of trades that have occurred in this exact, like just for this match. So not all the executed trades. We can have a separate API for that, but this match is just going to return the amount of trades for this match. Or we could do like true, false. If true, if a trade has occurred, but maybe not. We'll have to, like, there's probably a better way to do this, because we'd have to show the user if, like, their user has been matched, or if their order has been added to the order book. But I guess it's kind of obvious with this. If the list trade is empty, then you can safely assume that has been added to the respective order book. But I'm just worried for partial trades, so maybe, but then you have to count through it. Anyway, so let's first just talk about the match. So let's have a list of trades that have executed, and let's look at the direction. So if order direction, so if it's a bid, we'll be looking inside the offer book. Just write my mouse here. So if it's a bid, we'll be looking inside the offer book. So the first thing is, if not self.offer book.
Passengers on Air New Zealand Flight
So if the offer book is empty, we don't even have to look at the rest of the book, because there's nothing to match it to. In this case, we can simply add this order right away into our
You must go immediately to gate 15.
Else, this
Your
means that there is an
aircraft is ready to
outstanding order we're
depart,
able to
and
do.
all other passengers are waiting for you.
We can do executed trades and remaining amount. Yeah. Because we'll be matching the bid into the offer book, so offer book.match, and we'll be passing in the order. And we're going to extend the trades, trades.extend by executed trades, and we're going to extend our executed trades by executed trades. Okay, these are some pretty bad names. Trades list. I'll just do trades here. Trades list, okay? Yeah. Now another thing that we need to check is if a partial meta has occurred. So if only, let's say this order, so this bid order, had 50 in it, had 100 shares, but only 50 of them got executed. and then the next available price wasn't good enough, so return 50. So we need to check that. We need to create a new resting order for this. So if the remaining amount is more than 0, we're going to first update the amount of quantity in this order by the remaining amount, and then we can create a new order for this order. We can create a new resting order for this. Cool.
Paging the 5 remaining passengers on Jetstar Flight 202. The 5 remaining passengers on Jetstar Flight 202. You must go immediately to gate 18. Your aircraft is ready to depart and all other passengers are waiting for you.
And in the end, we'll be returning the trades list. Cool. So this is it for a matching book using a heap. Okay, so we actually fixed a bug. It's not really a bug, but one of the performance issues was that before, I'll show you what it was before here. So before, what we had before was that, so if the best price was, yeah, so that's for offer book. If the bid price was, so this is true, then we go over for every order in the best price and the order list. Now the problem here was that we're going to be trading the minimum, right? So that means for this case, either one of the two will always go to 0. And it's fine if the order goes to 0, but let's say the bid goes to 0. So the bid goes to 0 and there's no more to be traded. But what happens is that there is no exit clause. It's only in the while loop outside here. So for this, we're going to still check every order within the order book, within the offer book for this specific price point, even though the bid quantity is 0. So a way that we could swap this is, instead of doing that, we're first going to extract the queue if the best price is good. So we're going to get the queue here, and then we're going to do a while loop. While there exist orders within our queue and the bid quantity is more than 0, then we're just going to do the same simple loop again. But what this does now, and we're just going to access the order as the very first element within the queue. So what this actually does is that if the bid quantity, so if the incoming aggressing order is fully completed, then we can simply leave this while loop without having to check literally all the other orders for no apparent reason, because the minimum here will always be 0. But everything else will remain the same, and this should be more performant than the option that we had before. And it's a bit easier to read as well, because we can get the queue here, and we know this is going to be a DQ that has orders in it. I don't even need to type this, I don't imagine, because we already know this is an order. Yeah, cool. That sounds good.